और भाई कैसे हो? आज है अपना लीड कोड का 107th डे। तो टुडे टू पॉइंटर्स क्वेश्चन, आई थिंक अब टू पॉइंटर्स क्वेश्चन ही आने वाले हैं इस पूरे वीक। सो द क्वेश्चन इज लेंथ ऑफ लॉन्गेस्ट सब array with at most k frequencies. Okay, so we'll see this question phase by phase. Okay, so first of all, the constraints for n is n less than equals to 1e5 and nums of I, right? Nums of I less than equals to 1e9. Okay, now let's read the question. So let's divide the part. First is we'll read question, right? Then we do a small brute force. Then we are going to use the two pointers. Okay, and the last is just code walkthrough. Okay, so we have four steps today. So let's see what we are going to do. Okay, so let's first see what the question asks. We have given integer array nums. Okay, and the frequency of element x is the number of times it occurs in array. Okay, we have given a nums array, and the frequency of each element is x. Okay, an array is called good if the frequency of each element in this array is less than or equal to k. Return the length of longest good subarray. So that means what we have given. So say 1, 2, 2, 4, and they are saying right there is a frequency k equals to 2. Now that means if we have to give the length of longest subarray such that frequency of each element is less than equals to 2. So consider this array and this array. So this array, right, 1 has a frequency of 1. If I consider this array, both 1 and 2 has a frequency of 1. If I consider this array, both 1, 2, 2 and has a frequency of, right, it has a frequency of 2 now. It's still less than 2. Okay. Then we consider 4 again has a frequency of 1. Now, if I include this 2, if I include this 2, it becomes 3. That means it's not a valid, right? That means this entire not valid. Okay. So what was valid? 1, 2, 2, 4. This is valid. Simple 1 is valid. 1, 2 is valid. 1, 2, 2 is valid. 1, 2, 2, 4 we have done. Then 2 is valid. 2, 2 is valid. Right? 2, 2, 4 is valid. 2, 4 is valid. Simple 2, right? Again for this index. So these are all valid, right? Now among all valid, right? Length of longest equals to what? 4. Right? Length of longest is 4. So this we have to return. We have to tell this length of the longest array that is valid. Brute force approach will be what? So brute force approach is right simple. What we are going to do, we write for this array for each position, right? From each position, you run a loop, right? Run a loop basically. So you go here till now. At each index, you keep updating frequencies. Keep updating frequency. If frequency, right, for some element is greater than k, that means break. Why? Because we need valid means what? At most frequency or so if any frequency greater than k, that means now it will be not be valid. So that will be the brute force approach. So I'm not writing code for brute force approach, but it's basically right. What is the time complexity for each position? We iterate each position one. Now for each position, we iterate the rest of the array as well. So that's both and cross and basically. So we'll get a TL. So we are not going to use this approach. Then now let's see another approach, two pointers approach. Now how this will. So what happens? Let's say this is array 1, 2, 2, 2, 3, 2, 4. So this is an array, and I will give you k equals to 2 basically. This k equals to 2. Then now what will happen? Let's say I start from this one. Now when I go, I do right frequency of 1 equals to 1, frequency of 2, 1 at this position, right? I again increase its frequency to 1 position. Now when I increase it to 2, frequency 2 is right, frequency 2 becomes immense, like no limit. So then now I have to starting from index to start. Now and now it's, anything other than in front of this is not valid. That is correct. So if it's not valid, that means now we don't have any point on considering this start position, right? Okay. So that means we can leave our start position now. We can change our start position. So that means now we can change our start position. Okay. So now if we can change our start position, then how we will change it? Now see, the frequency of 2 was 3. If we are on this start position, now for this index, right? For this our right pointer, our right pointer j to be valid, right? Mm, 1 second now. Okay. So for our right pointer to be valid, we need frequency, right? We need frequency of 2 less than equals to k now. So that means what do? We do increase our left, right, till this condition is satisfied. So that means now we'll move our this pointer. Okay. So we'll move our start, right? We move our start here. When we do, frequency of 1 becomes 0. Okay. Now when we come in this position now, if still the frequency of 2 is 3, right, there is no change to frequency of 3. Okay, then when we come on this point, we move it again. Now when we move, this 2 is removed, right? When this 2 is removed, now frequency of 2, right, frequency of 2 is now 2. That means this is a valid frequency. So if this is valid, now this will be our start position. Now from this start position, this end is valid. This end is valid. So if this end is valid, then we will continue our loop ahead. Okay. So for this, now what we are going to do, when we come to this position, now we have frequency of 1, 0, frequency of 2, 2, frequency of 3 becomes 1. When we again come this position, this become plus 1, which is again 3. Now if it's 3, that means it's not valid. So that means it's not valid. So if it's not valid, we again move our left pointer. Okay. So we have to move our start. So we'll start this to we come to this position. So when we come to this position start, this one reduces. So now frequency become 1, 0, 2, 2, 3, 1. Now, so see in initial one, this was one valid, this one was valid. So length equals to 3. In the second phase, these two are valid. So length equals to 2. Now, see now when we come to this position, this becomes invalid. So we move our start position to here now. So when we move our start, 3 becomes 1, we come another 4, 4 becomes 1, and we are at the end. Now our length equals to what? 4. So is this 4 biggest? Yes, 2, 3, 4 biggest. So this will be our answer. So, so that is the two pointers approach basically. So now the approach is very simple, right? So what we have done, we have taken fixed steps. We maintain two pointers, left pointer, right pointer. We keep iterating right pointer until frequency of right element, right, it increases k. Now if it increases k, we need to reduce it by 1. That means now we will shrink our left pointer until we reach this nums of I again and it becomes less than k. So that's what we are going to do. So we will have a left 0, right 0. Okay. Now while right less than, and what do we are going to do? See, we will do frequency of nums of r plus plus, right? We increase the frequency of a right element. Okay. Now if we increase the frequency of a right element, then if this frequency, right, if if this frequency if this frequency of nums of right element, if it's become greater than k, that means we have to remove it. Now we will remove until we, so we'll keep removing left until we haven't reached this. So instead of if, we should use a while here. So instead of if, we should use a while here. Okay. Now at each position, what we are going to do, so this coloring is becoming really difficult. Okay, so now what do? We remove frequency of right. Okay, so we'll do frequency of nums of our left position, right? We subtract it. When subtracted, we increase a left plus plus. Okay, now, and after this while loop, when it's valid, we get our answer equals to maximum of answer, comma, the right position minus left position plus 1, and just return answer. So this is it. And why this r minus l plus 1? Let's see, this is l, some 0, 1, 2, 3, this is r. Now, If index wise, see r minus l equals to 3, but its length equals to what? 4, because these are index weights, so we do r minus l plus 1. So that's it. Now, what is the time complexity of this approach? Time complexity equals to what? You see, every element we traverse, see, we keep on traversing, but if whenever frequency greater than k, we move our left. But at none of the point we repeat everything two times. We don't, for each position, we don't run the loop. We just keep moving forward. And if at some point it become, we bring our left towards us. So at the end, we just have run the loop n plus n at max. So the time complexity will be of n only. Yeah, that's it. So okay, so let's quickly see the code part. We are going to use the two pointers approach here, right? Then we see what do we do? We check if frequency greater than k for some element, right? If yes, we move our left. Okay, so we do until left equals to 0, and we need an unordered map. So we cannot use a, what do we say? Okay, this is the earlier error now. So we cannot use a, right, the array here. Why? Because this uses the 10 raised to power 9 nums of I. So if you initialize the array of 10 raised to power 9 size, you will get this MLE. So that's why we are going to use the unordered map here. Then we simply, this I will be a right pointer, I less than nums dot size, I plus plus, what do we do? Map, right? Map of nums of I plus plus we do. Okay. So if at any point, if this nums of I, right, if it becomes greater than k, then what do we do? Then we subtract the left one, right? Left of plus plus minus minus. Okay, and then we have to update our answer. Answer equals to maximum of answer comma what current minus whatever is the length of the window now, and we return simply answer. So we have to initialize the answer as well. And initial why one initially, because the one character is always valid. So let's see. Oh, it's L only. Correct now. So once you get to the approach, right, which approach you have to use, then code part is easy. So first always try to find out the approach. So yeah, let's see. Good. So let's see what this 100% people have done. So they has an unordered map like us. Okay, they it's just they kind of similar. What did they do? They took a pointer, so that's why they did not access this value again. They have a pointer to it, and they keep decreasing it. They not equals to nums of I. They, okay. So is that mathematically, like, it's mathematically optimized, not in terms of time complexity. So if we'll see the time complexity, that will be O of n, and that will be the optimal time complexity that we can reach here. So you see, excellent work. Okay, code is clean, concise. Okay, that's fine. So whenever you write, whenever in an interview, if someone asks this question, and this is one of the hot questions that are going to that people generally ask. If I will be an interviewer, if I have to take some intermediate level interview, I'll definitely ask one of 2 pointers question. So just solve some questions on 2 pointers, and it will help you a lot in the long run. Thank you.